Dr. Tim Fiore, who AVH hasn't, a lot of AVH hasn't met yet. Dr. Fiore is a MD homeopath in Illinois. He's one of the leaders, or the U.S. leader, of Andre Saint's Materia Medica Pure project, and has researched and presented some amazing awesome remedies and added thousands of additions to the new repertoire. He also runs the Illinois Medical Homeopathic Society study groups that we're all invited to attend. Tim is a busy guy, so Tim, I don't want to infringe on your full presentation, so we'll look forward to hearing from you right now.
All right, Jeff, thanks for that introduction. Is it better if I show myself or not show myself?
Well, that's totally up to you. You might want to start that way.
Okay, I'll start that way. And Jeff, could you monitor questions?
I certainly will.
Okay, and then you can just, I think if we go along and people have questions, just go ahead and interrupt me and we'll take questions.
Okay.
I've got a lot of slides. I don't know if we'll cover them all, but here goes.
And your webcam, Tim, if you're going to show your video, your webcam is cutting you and your head off the top.
Okay, so
there you go. Perfect.
So let's start the slides. All right, so I understand you guys have heard about nanoparticles and homeopathy from Iris Bell, who is my teacher on this subject, and I believe also you have a member of your group who have done presentations on nanoparticles, so that's great. So I'm going to leave out the elementary stuff and kind of get into some interesting stuff, talk about stuff maybe you haven't talked about so much before. We'll run through the basic studies and then go up to more recent studies by Iris Bell and others, and other. You know, one of the interesting things about nanoparticles is how do they influence the body? And so we'll talk about like stochastic resonance. What does that mean? We'll talk about time-dependent sensitization. What does that mean? Et cetera, et cetera. So let's get started. So how does homeopathy work? I mean, that's the question du jour. And it seems like homeopathy is becoming a form of nanopharmacology. That's sort of where the science is going. Okay, advance here. We all know the issue is when you make dilutions, you start off with a mother tincture, you do one here centesimal dilution, so it's 1 to 100, and you succuss it anywhere from 2 to 100 times, and you keep going on as you dilute. Once you get past a 12C, you basically, you know, you start with a mole or less of a substance. So once you get beyond 12 to the minus 10 to the minus 24, you've basically diluted out the active ingredient, theoretically. So all these potencies, 30C, 200C, 1M, 10M, etc., are all beyond Avogadro's number. And this is what makes the skeptics apoplectic. They're, you know, I've heard one quote, they said, you know, the visible universe only has from 10 to the 78 to 10 to the 80 atoms. Look at these dilutions here. Anything really, even a 30C, it's approaching that, and by the time you get to 200C, it's way beyond that. So their way of thinking is, well, it can't work. Well, luckily the material scientists, who are the ones who deal with transistors and integrated circuits and stuff like this, they understand that some things that don't seem like they should work do work. And the analogy I use is, well, I can look at a plane, and I live by O'Hare Airport in Chicago, and I mean, these big planes, how do they fly? I mean, I can't understand it, but they still fly. It's a law of aerodynamics, laws of physics. So just because I don't understand it, like the skeptics don't understand it, doesn't mean that it doesn't work. There are many hypotheses how homeopathy could work. Memory of water, Jacques Benveniste published on this. He looked at dilute solutions of IgE, diluted beyond Avogadro's number, and they were still able to degranulate basophils. As a reward for his work, he basically lost his research funding and was ostracized from the medical community and the research community. And even though he was on track to get a Nobel Prize because he was the discoverer of platelet activating factor, he basically, his career was short-circuited, and he actually had heart surgery and died shortly thereafter, about maybe 5 to 10 years ago. Kind of a sad story. Epitaxy is another possible explanation. This is where, when they make transistors, if you put something next to a silicon crystal, it will change the structure of the crystal. And even though there has been no passage of material between the two, the structure of the silicon crystals are changed, and therefore the function will change. Clathrate formation, hydration cages is one possible explanation from the past. Coherent domains. There's a silica hypothesis that actually silicates from the glass and siloxanes from the glass actually form particles that, and maybe nanoparticles that contain the information. And then finally, the nanoparticle hypothesis, which states that there are nanoparticles of the starting materials in the homeopathic remedies. I think actually all these theories may have play. There's certainly a lot of studies have shown nanoparticles. There's studies now that are showing the nanoparticles sometimes coated with silica. Because of how water works now, I'll mention some of Gerald Pogg's work on what he calls it is exclusion zone water or easy water. It's liquid crystal water. It's very organized. It almost forms like coherent domains. And certainly a nanoparticle maybe is a coherent domain. And water does some interesting things. So what is nanopharmacology? It basically means you're just dealing with particles that are smaller than 100 nanometers. And to give an idea of perspective, that's 10 to the minus 9 meters. When you get to 10 to the minus 10 meters, you're dealing with atomic radii. Like for sulfur, phosphorus, about 1 angstrom. That's 10 to the minus 10 nanometers. 10 to the minus 10 meters, excuse me. The cool thing about nanoparticles is they can exhibit properties that are different from bulk materials. For example, gold is non-magnetic, yellow, and not a good catalyst. Well, certain sizes of gold nanoparticles can be blue. Certain sizes of gold nanoparticles can be very chemically reactive, a good catalyst. And certain sizes of gold nanoparticles are actually magnetic. This is the...
Sorry to interrupt him. Are you advancing your slides? Because I don't think we're seeing that. We're still on the first slide.
Oh, yes, I am.
Okay, so I believe...
What's going on?
Yeah.
Maybe I have to take off my...
Yeah, you may have to stop your webcam. We may actually have to disconnect you and have you reconnect. But we're still...
I'm on a slide that says, what is nanopharmacology?
Yeah,
Can
no.
you see it?
No.
And it says nanoscale versus microscale. You see it?
No. Let's see. Yeah, sorry. Yeah, it's... okay, let me try taking you away from presenter. Right, Tim, I'll send you a request for keyboard and mouse, and then I'll send it right back to you.
So should I say give or deny?
Yep. Yeah, give. Go ahead and approve them. Did you do it?
I gave you control, yeah.
Huh. Okay, let's see if I can switch. Yeah, it still got you as a presenter, unfortunately.
Let me advance my slides. Oh, I see it was at the beginning.
Yeah, no, it shouldn't even be showing your slides, yeah.
Is it better if I go out and come back in?
Yeah, at this point you might have to. Sorry, guys. Wait a sec. What is this here? No? So yeah, you may have to go out and come back in. Sorry about that.
I'll quit and then I will go back in the link. I'll
All
go
right.
by the link again.
Perfect. Sorry, guys. While we're waiting, sorry about the tech snafus, but I do see people still arriving. So as soon as Tim gets back, we'll start all over again. Or start from where we left off, either way. Or, okay. Slides. I'm going to start
Okay.
the recording again. All right. And don't forget, if you want to record, you have to hit recording again.
Oh, you have to give me that privilege. I don't have that privilege right now.
Okay, right. Sorry. All right. Okay. So it's all yours. Sorry, guys.
I went through these different hypotheses, and actually, maybe it has to do with all of these because you have nanoparticles. That's been shown. Silica is involved. They involve coherent domains, and especially when you get quantum dots, 10 nanometers or less of nanoparticles, it forms what it has quantum properties and maybe possibly coherent domains. And then there's water, something to do with water, because when the remedies and the nanoparticles are in the body, they form. The way I like to think of it is like the exclusion zone of water. It has a charge. It almost forms like little batteries. So we'll talk about that a little bit if we have time. So nanopharmacology, less than 100 nanometers. So it has to do with like a few molecules, tens to thousands of molecules, but not, or atoms, but not single atoms, but not bulk material. They exhibit different properties. You can see the nanoscale here. Here's a 100 nanometer versus a cell here in mitochondria. And especially when it's less than 100 nanometers, it can easily get through the cell membrane and the nuclear membrane. And in fact, these homeopathic nanoparticles have been shown, and homeopathic remedies have been shown to affect gene expression. So this is the first study. These were scientists in India Institute of Technology in Bombay, or Mumbai, and Chukramani 2010. They're the first ones they looked, and they said, oh, there's supposed to be nothing in these remedies, let's look. And they looked at just metal remedies, and they found potencies 30 and 200C showed nanoparticles of the starting metals in their aggregates. The transmission electron microscopy showed the particles. Electron diffraction and chemical analysis with atomic emission spectroscopy actually demonstrated that they were starting materials. Here's just a few pictures from that study. There's a lot more in the study. This is 100 nanometers. You see a nanoparticle here. Here you see bigger particles. These are probably actually agglomerations of nanoparticles. Same here. This is stannum metallicum, 30C and 200C. They found in every metal they looked at, they found nanoparticles in all potencies of 30 and 200. And in the picogram range, that would be like parts per billion, 10 to the minus 9, and 200 to 2,000 picograms per milliliter. There was a plateauing of concentration after like around 30 to 200C. So we have to ask, if the concentration of nanoparticles plateaus, how does the effect of the 200 and higher change? There's actually one cool study by Gosh, which actually shows that the nanoparticles get smaller, and that's why those higher potencies are different. I'll show you that study. And so for those who say, well, it's just a few picograms, how could it be significant? Well, this is within the range of active hormones like T3 in the body. Free T3 is only the 2 to 4 picograms per milliliter, same range. Estradiol 13 to 54. And this also falls within the range of hormesis, which we'll talk about a little bit if we have time, which is 10 to the minus 6 to 10 to the minus 12. Here we're dealing with a 10 to the minus 9, so it's right in that range. Problems with this study: they didn't use any controls, only metals, only up to 200. And how do you explain how are the higher potencies different if the concentration of nanoparticles plateau at 30C? And why do the concentration of nanoparticles stabilize? So the same author and others, Chikramani, they actually published this in a very prestigious material science journal and 2 years later in 2012, Langmuir. And what they basically came up with is hypothesis: why do the nanoparticles persist despite the dilutions? And what they came up with is a froth flotation model, and then they tested it and saw, in fact, this was what was happening. So they say basically extreme dilutions, 30 and 200. The presence of both of any active ingredient and the therapeutic efficacy has been contentious, to say the least. Studies, but now at this point, studies of these solutions have unequivocally established the starting raw materials in nanoparticle forms, even beyond Avogadro's number. And they have a hypothesis to explain it. They say once the bulk concentration is below a certain threshold of a few nanograms per milliliter, that's 10 to the minus 9 nanograms, 10 to the minus 9. I guess picograms are 10 to the minus 12. At the end of all the nanoparticles levitate to the surface, accompanied by a monolayer at the top. So they basically form a monolayer. And this is what is preserved and carried from step to step. So the dilutions are only apparent. So here's the graphic in the article. The lattice here is the lactose. The little black dots are the metal nanoparticles. The white dots are air bubbles. And you can see the model here is the air bubbles kind of take the nanoparticles, levitate them to the top, and form a monolayer. And once you get to a certain low concentration, this monolayer is preserved from concentration to concentration to concentration. So the dilutions are only apparent. And another interesting thing that happens is if it's a glass bottle, or actually probably any kind of substance, but especially glass, the nanoparticles will adhere to the bottle. And as you keep diluting, if you use the Korsakoff method, they will remain in solution and come out every time you add more solvent. All right, here's another study. This was published, so that last one was in 2012. This is 2014, American Journal of Homeopathic Medicine. Ghosh here tries to explain how higher potencies could be different, because if the concentration of nanoparticles peaks, how are they different? So he looked at cuprum metallicum, and he looked at its action on biological membranes, 6C, 30C, 200C potents. And since the membranes are the primary site of action of most medications, he looked at membrane fluidity, and he found that the homeopathic remedy fluidized the membrane at all potencies, but less at higher potencies. And this seems to be because the drug particle size decreases. So he says for this time, certain target effects of homeopathic medicines can be explained from a regular physical chemical point of view. And here's the graphic showing, here's this is 200 nanometers, and you see in the 6C, the nanoparticle size is between 10 and 20 or 30 nanometers. Here, this is 20 nanometers. In the 30C, it's between 1 and 2 or 3 nanometers. And you see here in the 200C, the cuprum nanoparticle size, and this is 2 nanometers, is less than 1. You can see most of these are less than half of this, so that's less than 1. So these are actually quantum dots. Anything less than 10 nanometers is considered a quantum dot and has quantum properties. So with increased dilution, the particle size goes down, and it makes sense. If you have nanoparticles and they're maintained in the solution in the monolayer, and you're shaking and adding violent shearing action on the nanoparticles, it makes sense. They're going to break apart. They're going to get smaller. It's logical. Here's a table looking at as you go down, the nanoparticle size goes down as you go up in potency. And he did a control, and the control showed no nanoparticles. Now, it gets very interesting in some of the recent research by Iris Bell, published in 2015. She actually found nanoparticles in the control solutions. And we'll talk about that in a bit. How could that possibly be? It kind of muddies the water a little bit, if you will.
Tim, she found nanoparticles of the original substance in the control solution, or
Well,
just
the control
nanoparticles?
solution did not have original substance. If you think of it as control, let's say you're making the remedy cuprum,
Right,
the
right, yes.
control would just be concussed water with a cork, and it has
Yeah,
nanoparticles, but it's other nanoparticles, probably silica and other things. I don't know that they have characterized exactly what the nanoparticles are, but it's not of the starting. It's not of the verum,
of the
because in the
medicinal
control there would
material.
not be verum. There would not be, if you're using cuprum as a remedy, you wouldn't have any cuprum in it to start with.
Right.
But there are, her research shows nanoparticles. I'll show you that study in a little bit.
Yeah, so it wouldn't be surprising to find nanoparticles necessarily of other original substances in the control.
Well, this is the skeptic's thing. Oh, so you have some nanoparticles, so what? But I think nanoparticles are not so common in nature. I don't know, because they're fairly toxic. So I mean, I think maybe more research needs to be done so we can see how pervasive they are. But according to Iris, basically the reason nanoparticles are in the controls is because they use a standard method of, I actually think standard homeopathic. They use glass vials and they use cork stoppers. And whenever you have organic material, actually that's one way of making nanoparticles from the bottom up. If you have like a solution of silver nitrate, if you want to make silver nitrate nanoparticles, you put the solution of silver nitrate in a plant tincture, and the plant, something about the interaction between the solute and the plant tincture, it creates nanoparticles from the bottom up. So whenever you have an organic material there, it tends, a plant tincture or something, it tends to create nanoparticles. So, but I think this is an area ripe for, you know, future research, like how pervasive are nanoparticles? I don't think we really know.
Yeah, I agree. Thank you.
Okay, so sure. So this solves a puzzle. So then he says here, rather than taking a defensive stance, homeopaths can begin to explain their field in contemporary scientific technology. And I find when I talk to audiences, I've given this lecture to naturopaths, and they can be kind of skeptical, you know, and naturopathic students. And when they see the pictures, I think pictures are worth 1,000 words. It's like, oh, the nanoparticles are there, and oh, you proved that they were starting materials. It's like, it's hard to refute that. Rajendran in 2015 extended our knowledge about homeopathic nanoparticles in homeopathic dilutions by, instead of using a metal, he used lycopodium clavatum, a very common remedy, polycrest. And he didn't just use 30 and 200, he went all the way up to cm. And what did he find? So the present study confirms the presence of nanoparticles in multiple potencies from 6C to cm. And here are the pictures. Here's a 6C, you see the nanoparticle? And these are all 200 nanometer dimensions on all these slides. 6C, 30C, 200C, a little harder to see, but they're here. 1M, they're more visible again. And here you're getting pretty big. These are probably agglomerations of multiple nanoparticles. The interesting thing about nanoparticles, if they have any charge at all, they tend to surround themselves with a halo of water, and then it's like the formation of clouds. There's a principle in water that like likes like, so it attracts other similar particles because of the charge involved, and so they tend to agglomerate. And it's interesting, when you succuss, you're probably breaking that up so that you can continue doing the dilutions and disperse the nanoparticles. Also, when you put the solution, the final solution on lactose or sucrose pellets, what you're probably doing is dispersing the nanoparticles as well. Here's a 10M. Again, very clear. 50M, rather large, probably an agglomeration. CM, look at the CM. It's just pervasive, these nanoparticles, about, I'd say, probably 20 to 50 nanometers. And the control had no nanoparticles. Here's the particle sizes. Now you'll notice Rajendran did not find the change in size with increasing potency like Ghosh did. But he did find lots of agglomeration, that might, in clusters, that might be why. And he didn't analyze for the starting material. All he did was look at carbon and oxygen. And you'll see at the different potencies, there's different amounts of carbon and oxygen. So the problem with this study because they didn't do an elemental analysis, you can't prove that they're starting material there. But with a plant product, this is very difficult. Why? Because we know Lycopodium clavatum has dozens and dozens of ingredients in it. So which chemicals are you finding? And it might vary from potency to potency. Nanoparticle sizes did not decrease, probably because of the clusters. He didn't present a hypothesis why there was a variation in carbon and oxygen content. And here I have a wordle here of Lycopodium with all the different things that are in it. You see all the different chemical substances that are in it. Now, if you ask a pharmacognosist, they would say, well, the active ingredient is lycopodiene, which is the alkaloid, has a nitrogen and several rings. But, you know, it's like Mozart said when the king criticized him and said, hey, your music has too many notes. He's like, well, which note is too many? Tell me and I'll take it out. How do you know that this is the only active ingredient? I mean, there's so much here. And it's interesting in homeopathy, when you take a remedy like belladonna, we use it so frequently. A remedy like lycopodium, we use it so frequently. But when you take Nux vomica, ignatia, they have strychnine in them. We use them so frequently. But if you take the supposed active ingredient and use that alone, like strychnine, like atropine, etc., it has a much lower, much narrower modus of action or use in homeopathy. That's been my experience. I think other homeopaths too. Those are remedies we don't see used much. They don't seem to have a very wide range of action. Whereas lycopodium in its native form with all these chemicals has a very wide range of action. It's a polygress. So homeopathy creates nanoparticles using a top-down strategy. That means you start with bulk material. And basically in homeopathy, we're grinding and polishing, we're milling. If it's like gold leaf, it's insoluble, we grind it with milk sugar according to Hahnemann's methodology. Or if it's a tincture, we shake and dilute and make it smaller and smaller. Like I mentioned, there are bottom-up strategies. These mainly involve other methods. And by a very green method of doing it now, they find if you take a solution and put it in contact with a plant tincture, you will get bottom up. You'll get from just a solution of something, it will self-form from none to it will start forming nanoparticles. Homeopathic nanoparticle manufacture is more green. Generally in conventional nanoparticles, they use some toxic substances. As I mentioned, nanoparticles are known to embed in the glass tube as you're making dilutions. And this might explain the Korsakoff method where you shake, you put a drop of the tincture, you put it in, you add water, you put it in a glass tube, you put a cork, you shake it, spill it out, refill it. Well, the nanoparticles are adhering, and that partially explains, maybe explains the Korsakoff method, why that works so well. Another thing is remedy source nanoparticles may dope or seed silica nanoparticles to create silica amplified signal. There's actually one study which I'll show you which actually shows with natrimere and kaliumuriaticum, it shows the nanoparticles of those two components, and then you see they're covered by a layer of silica. And they say, this author says, well, that's probably how all homeopathic remedies are. And it's even more complex than that because when you do electron microscopy, you're evaporating off the water, the solvent, and you're just left with nanoparticles, and you're taking pictures of those by adding, copper or carbon or something. But in the body, these nanoparticles associate probably with proteins, with water, and form probably very complex structures. As I mentioned, drawing nanoparticles onto lactose is used to reduce agglomeration and stabilize. And because of the nanoparticle size, it explains how some people can olfact remedies, or they can be used oral or actually through the skin. These nanoparticles, especially the smaller ones, can cross cell membranes easily, and nuclear membranes, and even the blood-brain barrier, especially quantum dots. Now, skeptics will say, well, so you found nanoparticles, big deal. Is it reproducible? Well, yeah, it's reproducible. 12 different labs, and I believe in North America, in Europe, in Asia, have reproduced these findings on different substances. They've found nanoparticles, some in minerals, some in plants, So this is a reproducible effect. Anyone who says, oh, no, it hasn't been reproduced, no, there's at least 12. And this was as of 2015. I don't know if there's more labs now at this point. Someone had a question? No. So here's a study, Tem Geyer, published in 2016, just last year, establishing the interfacial, nanostructural, and elemental composition of homeopathic remedies. Basically, these are the guys who said, we propose a universal hypothesis that all types of homeopathic medicines consist of silicate-coated nanostructures dispersed in solvent. And here are the pictures. So this is Nature Mirror 200. This is Cali Mirror 200. And here you see, this is the Nature Mirror crystal in the middle, and it's surrounded by this halo. This halo is silica, silicate, silicon dioxide. And they did electron diffraction. And here you can see the fact that they're dots instead of just rings means it's a crystalline pattern. Same here, different pattern. And electron diffraction shows these are the elements that are present. Again, the copper and the carbon are used in the electron microscopy process. But here you see a spike for sodium and chloride, because this is sodium chloride. But you also see silicon and oxygen, silicone and oxygen. Well, that's the silicate. Same thing with Cali mirror. You see the Cali muriaticum here, and then a coat of silicate. And again, the copper and the carbon from the electron microscopy. But then you see potassium chloride, which is what Cali mirror is, and also silicon oxide. Now, to muddy the waters, Bell published a study in 2015, as I mentioned, and she looked at argentum metallicum, silver, 6C, 30C, 200C, and she found nanoparticles with a range, about 90 nanometers with a range, confidence interval here, 100 or 105 to 80, pretty much. So all of them had nanoparticles. But then she did some controls. Here she has a succussed ethanol control, which was in a glass tube with a cork, and it still had nanoparticles, but they were smaller. And a succussed ethanol control, 30C and 200C, still nanoparticles. And here's an unsuccussed ethanol control, but in a glass bottle with cork, it still had nanoparticles. So if everything has nanoparticles, how do you differentiate the good ones from the bad ones? What you can do is look at Zeta Potentials. This measures the potential of the particle versus the solvent, and it is a measure of stability. If it's more than 30 millivolts or less than 30 millivolts, the nanoparticle is more stable. And you see in the verum, the argentum metallicum 6, 30, and 200, the nanoparticles tended to be higher zeta potential, which means more stable. In the controls, they tended to be less 30 minus 30 millivolts or less, closer to 0, so they're less stable. She showed the same thing for gelsemium. I don't have those slides here. This is another publication. This is from 2013. So basically what happens when you're using nanoparticles, with the bulk form, this is a hormetic curve where high doses cause inhibition, lower doses, and this is the no observed effect level, no observed adverse effect level. So toxicologists only generally look to here, but if you keep going down, you find that there's stimulatory effect. Well, in the bulk form, that curve is shifted this way. For nanoparticles, it's 10 to 1,000 times lower for similar effects. Smaller doses are needed and similar amplitude effect. Now we can ask the question, how do nanoparticles affect the body? So, okay, you have these nanoparticles, you sniff them, you put them on the skin, you ingest them. How do they affect the body? They're so small and maybe they shouldn't do anything. Well, we know that, in fact, so the nanoparticles have a certain identity, but when they're in the body, there's evidence that they form a protein halo. And I would suggest also that because this is charged, it's going to form a water halo too, of easy water, organized water around it. And this can have physiologic effects. in 2015, Bell published this, that basically the way remedies work with these nanoparticles, they don't work. We're used to the lock and key model. You have an agent, it goes and binds to a receptor and produces a pharmacologic effect on that receptor. And of course, it produces 1,000 side effects, but we ignore that in conventional medicine. But the nanoparticles are probably working not so much in this direction, but in this direction. They're not working by lock and key, they're working as a stressor. It's if the nanoparticle is salient to the individual, it's the remedy the person needs, it's like a stressor, and it stresses the patient in the same way that they're sick, and then they get a reaction. And the reaction occurs through the danger signal effects in the body, through the autonomic nervous system, the nervous system, the immune system, cytokine release, et cetera, et cetera. And there's even studies showing changes in genetic protein transcription, et cetera. So activation and deactivation of genes. So the focus for science, basic science and preclinical research. So we talked about the remedy has nanostructures. Luc Montagnier is looking at electromagnetic signals in water that's been diluted. It starts off with pathogenic bacteria, and you filter out the bacteria or their DNA, and then you make homeopathic dilutions. It has some remaining electromagnetic signal. There's optical signals, quantum effects. So you have these signals, and then you put it in the body, and then how does it affect the body? There's different ways that we can look at: stochastic resonance, time-dependent sensitization, and hormesis. Let's talk about those now. And then it's affecting the immune system, etc. And then you get the body we know is a nonlinear dynamic system. It adapts, and you get healing. So we could ask, how could the body even detect such a weak environmental signal or threat? One way is what's known as stochastic resonance. This is actually, it was first studied to determine how ice age is formed. How could you, there's little tiny temperature variation, all of a sudden you go into an ice age. In the 1980s, they came up with this model of stochastic resonance to explain it. Basically, it's an amplification of a weak signal by superimposing a noise with some overlapping frequencies. It's studied in the sensory neural system. It's interesting, you could have a lot of noise, but a mom hears her baby cry because or like a penguin hears its mate or its child cry, even with thousands of penguins. How? It's like it's able to just pick up that data that it needs and ignore all the rest. It only occurs in nonlinear complex systems like the body or a living organism. So the disease, we can look at it, the disease is what's creating the noise. That's what amplifies the signal. And so salience is more important than magnitude. It's like the hair, you hear the example of the hare smelling the fox. I mean, there's so many smells out there when a rabbit's sitting there and just crunching on the grass or crunching on my garden. But then there's also foxes out there, and it gets a whiff of the fox, and even though with all the other smells, it's salient to the organism because it knows, hey, I'm going to be lunch or dinner if I don't get out of here. So that gets amplified, that signal gets amplified, and it gets out of there. It affects gene expression. So this is how stochastic resonance works. So, okay. You have a background noise and a weak signal, which when it gets to a certain point, the noise amplifies it, and you get an output. And here's the weak signal in red. Okay. Here I have this is stochastic resonance, was discovered and proposed in 1981 to explain the periodic recurrence of ice ages. It's been used in a variety of systems. It's commonly invoked when noise and nonlinearity concur to determine an increase of order in the system. Okay, so that's one way that if you have background noise, which would be the disease, you have the signal from the remedy. It could, if they're salient, it could create a response in the body. What about time-dependent sensitization? We find with our remedies that we don't have to give them very often, but they can have effects for a period of time. How does that work? In standard pharmacology, we know very little about this, but there is some interesting stuff. In psychopharmacology, which is the area that time-dependent sensitization has been the best studied, you go to a psychiatrist and they say, I want to put you on an SSRI, but it'll take 6 weeks to work. Why is that? And logically, it's equally plausible that, well, if you give it every day, or maybe you just give intermittent doses, maybe you get the same effect. You don't know unless you test it. That's time-dependent sensitization. And in fact, researchers have looked at this, and they found for many endpoints in drugs, even ECT, electroconvulsive therapy, that they find time-dependent sensitization. First described in 1980 in animals. It's since been clinically demonstrated in humans with antidepressants and electroshock studies. I'll show you the studies in a minute. And it's long-lasting. It can be months. And the effects increase with time. So even though the original material that started the reaction is no longer there, so it's not pharmacologic. It's some other, probably gene expression or something else is changing. It's a pre-immunologic response. It's a danger signal. And this organism sensitizes to it, even after one exposure. It's clearly non-pharmacologic. If you give amphetamine, Haldol, and even the vehicle for Haldol, they have the same time-dependent sensitization effects. And two of them together have even more. We've long known that vaccines induce time-dependent sensitization, but only recently have we ascribed this to drugs. I mean, we're all familiar with, in my practice, I see kids who are immunized and they have effects for a long time. What is this? It's only one shot, maybe, but if the system is sensitive, it's maybe been primed by previous immunizations, and all of a sudden you get an immunologic response, an autoimmune disease. You get autism. You get allergies and asthma and eczema, which are probably the most common manifestations of vaccine injury. And parents are always surprised when I say, look, this is probably a vaccine injury. We're trying to treat it, but it will take time. It's like, why? You give a remedy, it should just go away. Well, no. Because of the adjuvants and other things added to the vaccines, they're meant to have a prolonged effect, and in fact, they do. The aluminum, it used to be the thimerosal, which is still in the flu vaccines. These things have prolonged effects in the body. It's more sensitive than immunologic memory, but more nonspecific. It's bidirectional, the same stimulus. If it's low, it can cause enhancement. If it's high, it can decrease the effect. And here's some studies. Dubé in '96, he looked at clomipramine, 250 milligrams. This is an antidepressant. And these are all people with a Hamilton Depression Scale of 21 to 24. 23 and up is pretty severe, severe depression. So these are people with pretty severe depression. And they looked at improvement in the Hamilton Depression Scale, days 3, 8, 15, and 23. So in Group A, 16 patients, they gave the chloripramine 250 milligrams once, and then they gave placebo for 22 days. What did they find? Day 3, 19% improvement. Day 8, 29. Day 15, 40. Day 60, 23, 62%. Then they had Group B, 11 patients. They gave the chloripramine 250 milligrams once, and then placebo for 7 days, and then for days 9 to 23, the chloripramine again. And look, the 8-day and the 23-day responses are the same, nearly the same. And then they had a control, 7 patients. They gave placebo for 8 days, and then for days 9 through 23, they gave chloripramine. And still, even though they were just giving placebo, at 3 days, the response was similar, 20%. It was less at day 8, but similar at day 23. Oops. Going the wrong direction here. Jagadish in '92, he looked at electroconvulsive therapy, 12 patients. They gave ECT, and then they gave 5 sham ECT treatments every other day for 5 days. I guess they hooked them up and knocked them out, but didn't do any ECT. They started with a very high Hamilton Depression Scale of 26. And you see the effects are about the same, 15%, 30 to 39% improvement, 64. And days 11 through 13, 73, 70, 84. Here they have 12 people. They did 6 ECTs every other day, and the same effects. Oops. It's called pulse therapy. Oh, I'm going the wrong direction. It can occur with the same agent, stressor, or cross-sensitized one. Like, it doesn't have to be exactly the same thing. Like a remedy, which is similar, could work. The dose of the agent can be low, but the size of the response grows with time. And that's what we see with homeopathic remedies, especially if you get a good chronic remedy for a patient, they change over time. We don't know exactly the mechanism, but probably immunologic, cytokines, nervous system, central nervous system. And if you keep repeating it, you'll get a reverse effect. And that's what we find with remedies. If we keep giving too many remedies sometimes, especially low potencies, but can be high potencies too, you can go from a beneficial effect to a negative effect. So TD, time-dependent sensitization, is a phenomenon where less is better. In cell cultures, time-dependent sensitization can persist across generations, even if the triggering stimulus is no longer present. In cell culture, it can be up to 10 generations they've studied. So this, because it persists, there's probably a genetic component. And it may help to understand disease development. For example, PTSD can occur from a single exposure, and it can progress over time. And dermatologists say that, well, if you got 1 or 2 bad sunburns when you were young, that will lead to, when you're older, melanoma. But it's interesting, when people have continuous occupational exposure, their risk of melanoma actually goes down. And similar with phobias. Usually phobias, it can be 1 exposure, but over time, the phobia can increase, even though the exposure does not happen again. Implications, so this study, Antelman in 1988, he says, well, this is an interesting effect. And in fact, drugs may have been given wrong for centuries, but can you imagine telling the drug company, well, you don't need to give your Prozac every day, you can give it once a month and it'll work the same. You're going to get a lot of doors slammed in your face. And here he says, depression and other diseases may be better managed with once every week doses rather than daily doses. It would save money and easier compliance, but the difficulty lies not in the ideas, but in escaping from the old ones, and certainly with the pharmaceutical industry from the profit motive. Although nowadays we do have drugs, it's interesting, chemotherapy now is occurring more in a pulsed way, like every 2 weeks, 3 weeks for different chemotherapies, the newer chemotherapies. Even the phosphonates, like for bone, preventing osteoporosis and treating osteoporosis, are given sometimes as once a month or once a year treatment. So this is starting to filter into conventional medicine. But of course, when they're only giving it once a year, I'm sure the price is going to be commensurate, be very high. What about hormesis? So what is hormesis? It's a nonlinear, biphasic response to a stressor, but it can be a drug or toxicant, in which high doses cause inhibition of function. Then you reach a no observed adverse effect level, and usually toxicologists only look till there. But if you keep going lower doses, basically you get stimulation of function. It's a very robust effect. Here, Calabrese in 2013-15, he looks at, okay, it can occur with nanoparticles. And what are the mechanisms? There are different mechanisms. It can be receptor-based. It can be for the stimulation and inhibition, the same receptor. It could be different receptors. And it can be cell signaling based, that it's changing some signaling within the cell and not just binding to receptors. And there's a couple studies here by Bush. There's different models in toxicology. One is that, as you keep going down, you get negative effects, but less until you get to 0. Then there's a threshold model, which is more common, that, you get to a certain no observed adverse effect level, and you get no more effect going down to 0 dose. But then actually the hormetic model is now becoming more popular, and you get stimulatory effect. This is hugely important for toxicology because, if this model is true, then no toxins in the environment are acceptable. This model says, well, small amounts. This one says, well, a little bit might actually be good for you. And there's a robust literature. There's a database of over 50, and this is from 2005. It's probably bigger now. 5,600 dose-response relationships for 900 agents. It occurs in males, females, in animal models, across species, plants, viruses, bacteria, fungus, insects, fish, birds, rodents, primates. It's a very robust, pervasive effect. And the endpoints, includes growth, longevity, metabolic parameters, cancer, cognitive functions, immune response. And it's reproducible that the maximum stimulatory response is less than twofold greater than control, while the width is about 100-fold in dose range. So it's very reproducible. And here's some hormetic curves. So this is inhibition down here. And as you get to lower doses, you see there's a stimulatory effect. This is with terramycin. This is with lindane, sodium chloride, chlordane, hydrocyanic acid, gamma radiation. So inhibition and then stimulation, gamma radiation, carbon tetrachloride, same thing. So we could ask, well, usually when you take a remedy in the body, what's happening there, because there's water involved. And so you need to be aware that there's some interesting research going on, although the memory of water, the Benveniste effect, basically, or fiasco as some would call it, basically stopped water research for a few decades. But more recently, there's people like Gerald Pollack, University of Washington, Seattle, who has started looking into this research. There's an excellent video at online on YouTube, Water, Energy, and Life, Fresh Views from the Water's Edge. He's actually continued doing this research on water. And the questions we could ask, so could it be that these nanoparticles and remedies serve as a nidus for liquid crystal water formation, and either the nanoparticles and the nanoparticles with a silica coating? And the way I like to look at it is, could these liquid crystals, could these nanoparticles and liquid crystals form like little batteries? I find when I take a good homeopathic remedy, one of the main things that happens, my energy goes up. I had a patient today who, you hear about it, giving remedies to a pet, a dog or a cat, and if it's a good remedy, the energy increases. And this is what kind of a pervasive effect in homeopathy. So how does that happen? Well, it's almost like we could be giving like these little batteries. I'll show you that in a minute. So the old way of thinking was that if you have a polar substance here, water would structure, but not very far. Now we understand that it extends very far, like probably thousands or millions of layers. Here's a gel with a charge. And what they do, what he does is take photomicrographs, and here's 200 microns, and they put little spheres in the water, so you can see if these are like little solute in the water, microspheres that you can see. Next to the solvent, next to the gel, you can see there's an exclusion zone where there are no microspheres. That's where the structured water is. It forces out the microspheres. And this is the easy water, liquid crystal water. Very long range. And it may be that much of the water in the universe is liquid crystal. This would explain maybe the advent of life. It's like, how can how could all these different substances come together and form life? Well, if there's liquid crystal water and it's structured, this could help enhance life, and he talks about it in his video. It occurs in biologic specimens. You see here is muscle, and you see this is where the easy water is. There's not, the microspheres are not there so much. Here's a monolayer, same thing. There's a pH gradient, more acid to more alkaline. And the easy water functions like a battery. Here's the surface of the whatever, it could be the muscle or whatever. In the exclusion zone, it tends to have a negative charge, and then it attracts positive charges in the water around it. Easy water molecules are more constrained, as you'd expect. They're more structured by NMR. That's been found. They're more stable. Has a negative charge, absorbs light at a certain frequency. It's more viscous, and the molecules are aligned. So easy water may be a fourth phase of water. Exclude solutes, negative charge, liquid crystal. And these could form around these nanoparticles and these silica nanoparticles. And this, again, could explain some of the actions. It's interesting here, when you have an air-water interface, liquid crystal water forms. And you wonder here about the formation, the way we make remedies. You might ask, well, how could water structure? You need energy to create structure, to create a structure like this. Well, in fact, the energy that you need is probably from either light something like that. So if light is available. And I know others have looked at like the Schumann waves, which are 7 to 14 to 28 hertz waves because of lightning around the planet, that these waves are pervasive. You can measure them. So that's the energy maybe needed to have this form.
Some people
forms
think
of
just the
light.
movement.
Excuse me?
It's Sue again, Tim. Some people think that just the movement of the water through certain patterns will create that as well.
Yeah, sure. Here's his book. He's got a new book out, even better. As I mentioned, when you talk about this phenomenon, there's a thing known as like. Like he asks the question, why do clouds form? You know, if you have water vapor in the air, why isn't it just evenly dispersed? Why do they form clouds? Because there's usually a nidus, a little nanoparticle, and then there's structured water around it, so it has a negative charge, and this one has a negative charge, but it creates, around it, it has positive charges that attract, and because of the positive charges, these two particles are attracted. So that's why clouds form. It's very interesting. Svent Gorny said, life is water dancing to the tune of macromolecules. So nanoparticles have been shown to have biologic effects on the immune system, cytokines, and even gene expression. They modulate gene expression. Here's arnica, and these are the various genes, and you can see this is arnica 5C, 9C, 15C. This is inhibition of the gene by whatever percent, and this is stimulation of the gene. So it has pretty interesting effects on the genetic expression. So getting to the end here, the complexity model. Basically, you take a remedy, you have a stable state, and the remedy triggers a dynamic destabilization, represented by this. And it depends on how sensitive you are to it. If the remedy is therapeutic, then you restabilize into a more healthier state. If it's not therapeutic, you just stay in the same state you were before. So you get the correct homeopathic remedy. It's a salient danger signal for the organism. The signal is amplified by, you can look at time-dependent sensitization, stochastic resonance, hormesis, and this creates a destabilization, maybe an aggravation, and then if it's a correct remedy, the organism heals. So that's my presentation. Any questions?
I believe that's suited. Suit, you there? Do you want to ask Tim your questions or afterwards?
Yeah. Thanks, Tim, for that really fascinating presentation. And I have a quantum physicist friend who's in Chicago that I'll introduce you to.
Oh, I'd love to meet him.
Yeah, he's really fun, and it was really fun talking homeopathy to him. And he's a serious water guy. One of the things that I've been sort of chewing on ever since we started talking about nanoparticles in homeopathy is something that you alluded to earlier in the presentation. And, you know, sort of there's sometimes, I think it's a two-edged sword. You know, there's sometimes that we can say, oh yeah, this sort of legitimizes the mystique of homeopathy and sort of makes it explainable and all of that stuff to folks that think it needs different kinds of explanations. But the other edge of the sword is, as we're starting to become more and more aware of nanoparticles, as you said earlier, that are, you know, dangerous, toxic, poisonous, and also nanoparticles that may have been used by certain factions in the world for skullduggerous matters rather than for health enhancing matters. And I've often wondered, how do we reconcile that within our community as we start talking about nanoparticles at the same time as the public awareness of the negative parts of nanoparticulate discussion are becoming much more in the forefront?
Well, I think, you know, that's an excellent question, Susan, and you know, I think the reason it took so long, it's taken 200 years to get here, is because, first of all, to research this is very difficult. You have to be very good at electron microscopy, material science, chemistry, physics, It's like it takes a certain scientist who's willing to go cross discipline. Most scientists stay within their discipline to even do this research.
Absolutely.
And I think that's why
Absolutely.
it's taken so long to get here. Now that it's here, yeah, we know that in conventional medicine we have a huge problem with with nanoparticles, because I know like Taxol now is a drug that for breast cancer, which they have a nanoparticle form, but what they find is it's so toxic, they have a hard time finding a non-toxic form of it. But I think the way
Exactly.
I look at it is, isn't it amazing that Samuel Hahnemann, 200 and some years ago, came up with this form of nanopharmacology just empirically. He couldn't see the particles. He just went by looking at patients, treating, trying different things, and seeing what worked. And he created the system. I think he created a very safe system.
It's flipping amazing.
You can use the most toxic substances in the world, and oh yeah, can people have some reactions and provings? Yeah, sure. But it's so much safer than conventional medicine that that's what I would focus on.
Yeah. No,
It's
I
interesting.
mean, I think it's flipping amazing when you look at historically that and this stuff that we've talked about and written about and speculated about. I need to dig through my work because I can remember 15, 17 years ago writing about how, in my opinion, we can get genetic changes through the use of homeopathic remedies, whether it's actually how the gene is expressed or actually changing the actual structure of the genome. And to see that get proven in the hard science lab is really exciting. And even, as you say, two centuries ago, that philosophy, the philosophical part of it was happening, even though the material part of it hadn't necessarily caught up with stuff. And I think it's flipping amazing. It's tremendously exciting.
It's only because Hahnemann was a phenomenologist. He didn't go by theory. He went by, okay, what works in patients. He was
Exactly.
had a phenomenological science that he followed, and because of that, he was able to discover this. I think nowadays, if someone tried to discover homeopathy the way he did, I think it would be very difficult. I think it would be very, very difficult. I don't think you'd be able to do it. I don't think you'd be able to do it. So I think, and it's interesting when I recently I went to a conference and we were at a hotel and we were in the elevator and someone said, "Well, you're at a conference? What are you at?" And it's like homeopathy. Well, what's that? I find when you tell people, "Well, it's nanopharmacology," that people get it. The guy was like, "Oh yeah, I get it. Oh, small doses, yeah, like and all that too." But
Yeah.
people kind of intuitively get it, and I think this has been one of the problems with homeopathy. Historically, they say, "Well, it's so diluted it can't possibly work," and that's kind of a logical criticism. And I think now we have data that we can actually tell those people, well, yeah, but look, there's actually something there. It's nanopharmacology, and it's kind of hopefully this can help homeopathy become more popular even in scientific circles. We'll see. I mean, there's still such a bias against homeopathy in the scientific world that researchers won't even touch the topic unless, like Iris Bell, she's kind of, she has a very long and illustrious career, and now at the end of her career, she can dabble in it and do research on it. For a young scientist to do research on this, their career will be over before they start.
Well, and I would hardly say Iris is dabbling, but yeah, she's out there breaking trail where many,
Absolutely.
have either feared to tread or couldn't tread for sure.
Oh, thank God for Iris. I mean, who else is doing research on homeopathy in the U.S.? I mean, good quality research. I mean, name them. I don't know who they are. It's all occurring elsewhere.
Yeah, yeah,
Any other questions or comments?
I think that I'm just looking at everyone, and nope, nobody has their hand raised. I can't see Anthony, Henrietta, or Judy. Well, if you have any questions, Anthony. Nope. So I guess we're all set. Tim, that was awesome. Yeah, I think the implications are incredible. I just don't know. Just don't know what the next step is going to be as far as, applying it in the real world. Yep, and the comments that we're getting are just it's fascinating, and, we have a lot to think about, and thank you for being here with us.
Oh, thank you so much. Thank you so much.
I think, Jeff, that the implications for the real world is we're going to actually start to have more meaningful cross-disciplinary discussions than we've ever been able to have before, because now we have a language where you know, those folks who were working in silos with their own separate, you know, micromanaging one particular little part of something are going to be able to actually communicate. So I think the potential is huge.
Great.
I agree, and I think also for the homeopathic pharmacies, I mean, you know, they basically, this is huge, because maybe now we have a way that they can do some quality control even at high potencies by looking at these sort of things. So I don't think any of the pharmacies are doing it now. It's probably too expensive or something to do it, but I mean,
yeah, they don't have the equipment.
There's a way. In the past, we had nothing. It's like the only way you could test a high potency is on a living system. You know, give it to a person and see does it do something. If there's, and they have to find someone who's sensitive. Now we might have a way of actually verifying that there's something in the remedy, and that the manufacturing process can be verified. So that's, I mean, for the homeopathic pharmacists, this is, I hope this is like a major breakthrough.
Short of electron microscopy, I'm wondering how Standard or Jim Clemmer or, you know, any of the pharmacists, how would they do that? What kind of equipment would they need to be able to buy to verify a 10M?
Well, there are studies. I know before Rustum Roy passed, he was very big. He said, yeah, there's definitely something to homeopathy, and we're going to be able to differentiate different remedies using different types of spectroscopy. And there are some interesting studies looking at UV visible spectroscopy and Raman spectroscopy, where you can look at a same remedy in different potencies, and the spectrum will be different, and different remedies will be different. So I think that's probably technology which is, I don't know, but I imagine it's more affordable. I don't know. I'm not a spectroscopist, but it seems like that's the type of technology that a lot of people have, versus electron microscope is.
Yeah, it's within the $250,000 kind of. Well, depends on where you buy the machines. I was just involved with a project that bought some, and you know, it's between $60,000 and $200,000, depending. You can get a good deal.
I imagine an electron microscope is probably in the millions.
Yeah.
And, you know, and the other thing is there's no reason that the pharmacist would need to have a machine in hand. I mean, all we need is a central place that you could set. I mean, you don't have to do your QC in house. If indeed, you know, if indeed that's something that folks want to do, there's no reason that you couldn't have a central place that already has the equipment set up to do your QC in house, particularly with
the FDA is smart. At some point, they might require that to, you know, and that would be a industry and testing of homeopathic remedies. There could be a company that could, you know, potentially test. Yeah, no, that's absolutely.
Yeah.
Great.
No, it's interesting.
Anything else, or anyone else? Any comments, questions? Tim, anything you want to add?
I think I've said all I want to say, but I'm happy to answer questions if anyone has questions.
All right.
Tim, you're going to give that, or Jeff, you've got those slides, so the references are there, right?
I can email the slides to you. I have the Jeff. I have a as a PDF. I can email it to Jeff.
That'd be great. Yep.
And I'll introduce you, Tim, on private email to my quantum physicist friend.
Oh, cool. So, yeah, I'd definitely like to meet your is it University of Chicago?
No, he's in a private company.
Okay, cool. I'd love to meet him.
Yeah, he's very cool.
So, Tim, thank you again. We really appreciate your time. Thank you all for coming, and we will see you next month. I believe Kim Leah is up, and we'll be talking pre-conference because San Diego is coming up.